Our topic for today is oxidation numbers. So there's so much explanation there. So the topic is oxidation numbers. Oxidation number of an atom is sometimes called the oxidation state. It represents the number of electrons lost, gained, or unequally shared by an atom. So number of electrons lost, gained, or unequally shared. So you remember that for a chemical reaction to take place, there is that process called bonding. And bonding is either ionic or covalent. So in ionic, the number of electrons the metal loses is the oxidation number. And in covalent, in ionic, the same ionic, the number of electrons the non-metal gains is its oxidation number. So I mean, when you're looking at oxidation number, you're looking at it from, in most cases, if it has a value, you're looking at it from the compound perspective. So in a compound, how many electrons were gained by this atom? How many electrons were lost by this atom? That's oxidation number. But then again, there is also sharing of electrons. So are you able to get me now? And guys, are you able to get me? Class, are you able to get me now?
Yes, sir.
Okay. So I was saying,
the network is being bad. Your voice is breaking.
Yeah, Zamtel. So the problem is Zamtel. So I was saying,
the network is bad. The voice is really breaking.
Nah, not
that much clear.
No, sir, we can barely get you.
Okay, you can get me now? Can you get me now?
Yeah, I think you're clear.
I'm okay now. It's here, the network, Zamtel did something on me because it even just cut. Like you guys, you cut. But this one is come back. Hope it doesn't do this. I should have stayed in school then. So I was saying the oxidation number is the number of electrons lost by the metal in ionic bonding, gained by the non-metal in ionic bonding, or unequally shared in covalent bonding. Because in covalent bonding, there's that aspect of unequal sharing of electrons. So oxidation numbers are integers, meaning they can be 0, positive, or negative. That's what an integer is. I'm sure you remember when you did that in your grade 4, when you are studying the number line. So if the oxidation number of 0 means the number of electrons assigned to an element is the same as when it's in its free state, when it's a neutral atom, then the positive oxidation number means it has lost electrons or it has fewer electrons assigned to it compared to when it is neutral. So it's oxidation, like when oxidation takes place, there is the gain of electrons, loss of electrons. So the one that loses electrons becomes oxidized. Then the one that gains electrons becomes reduced. So the one that is oxidized will have a positive oxidation number because it will have fewer electrons. So if something loses electrons, then it will have a positive oxidation number. So now the same thing, now we come here and say the oxidation number of an atom that has lost electrons to form an ion is the same as the charge on the ion. This is straightforward. So meaning, if you look at this table, these are the charges, these are the common ions, monatomic ions that are there. So if you have an ionic compound containing sodium, which is always the case for us, so if something contains sodium, like say sodium chloride, then it means that the sodium is the ion. So you have Na plus and Cl minus. So the Na plus, its oxidation number is +1. That's as we have said there. The oxidation number is +1. Then for the Cl minus, the oxidation number is -1. So that is the case. So for ionic bonding, it's very easy. The metal will have a positive oxidation number equal to the charge of the ion. The non-metal will have a negative oxidation number equal to the charge of the ion. But now the problem comes in when there's covalent bonding. So in covalent bonding, the only case where you have a symmetrical, because the oxidation numbers now in covalent bonding are assigned based on electronegativities. Based on electronegativities. Meaning the most electronegative, if you remember when someone had asked what is electronegativity, we said it is an affinity for electrons. The desire for an atom to gain electrons, or that power for an atom to get electrons. That is electronegativity. So the atom that gains electron more is electronegative. But then for these are both nonmetals, and it's covalent bonding. But even them, the only case where there is no difference in electronegativity is when you have identical atoms like these diatomic elements, H2, hydrogen and hydrogen. These are equally shared. These are equally shared. But then as long as it's like we're saying love for family, it's equally shared. Are you getting? If you love your sister, you love that person unconditionally, because like even when you love your mother, you love them unconditionally because you are born to be with them. But then if you have unlike atoms, there is no equal sharing. Even nangumuli muchitemu ikofilia. Takuba sana equal sharing. Sometimes you find your friend iwo alimubika pa DP ku 20 na 0 abika feri mbiutoni na ngoma nani ama abena King Julian balaba aba ku Disney. So you discover that you put in more, iwe less. Even like say you are sharing a meal, you will still provide the meal, the shima and the reddish. Your friend there is an assault. Then you say, I know not what to share na ngate ngatadide if you assault. So like there's that kind. So if you have two unlike atoms, just like two different people, it's difficult to have the same kind of love for each other, for them. Like if you, even you guys, you know what I'm talking about. Am I lying? Am I lying, guys? So those are the things. So now,
Zone.
okay. So now, we're talking about these things. So now, in this case, electronegativities, guys, they are on the periodic table. So the most electronegative, if you remember, was fluorine. So even electronegativities, you can Google about elements, you can see their trend. My internet is tripping again. Is it back? Am I back, guys? Can you get me, guys? Oh.
Yeah, you are.
All right.
You are clear anyway.
All right. So now I'm saying, in this
Yes,
case,
sir.
the most electronegative element is the one that will get the atom, the electrons. So the electrons will be assigned to the most electronegative element. So in this case, guys, of ammonia and water, these are common day-to-day substances. These compounds are common day-to-day. Water, you know it. Ammonia is also a very powerful compound that we use in the lab a lot. It's key in the making of fertilizer. And it has a very bad scent. Ngawayumfa ni urine feitunduru. Urine. Those of you who are asthmatic, you can't be in the presence where there's ammonia vapor. You'll be choking throughout. But as a lot of uses, one of the best uses it has is also it's a good cooler. When you place ammonia in a tube where there are varying diameters and it's just passing there without anything, as long as there's that, it expands, compresses, it becomes cold. So that kind of tube is what is placed inside the beer when you're working at breweries, when they're making castle. So to make the beer chilled so that it doesn't become hot, and the enzymes, ichimena cha sasa, they cool it with ammonia. Very good. But in if exposed, so it's highly like a chalk. So those are things. So I'm saying nitrogen here and oxygen, these are electronegative compared to hydrogen. So the electrons will be assigned to hydrogen, all of them, all three of them. So I mean nitrogen in this case will have +1 because hydrogen is just monovalent. So now remember guys, one of the things that I haven't said is that the same word oxidation number is what you guys used to call in grade 12 valency for ionic compounds, because valency was how many electrons it needed to be stable. But then for us at this level now, number, we're not using the word valency. You can use yes the word valence electrons, meaning outermost shell electrons. But in this case, instead of saying valency, you'll be saying oxidation number. Even in water, the hydrogen is assigned the positive, so meaning it is +1, and all the electrons will be assigned to oxygen. That's why oxygen is -2. But then this explanation is not very key. I don't want to kuchula sana. There are rules on assigning oxidation numbers, I think, but I've explained a bit there. So the oxidation number, if someone asks you, what is oxidation number? Define it. Then you say the oxidation number is an integer value assigned to a definition here, guys. Who is what the master it assigned to each element in a compound or ion that allows us to keep track of electrons associated with each atom. Then the uses of oxidation numbers are: one, we use it to write formulae. Then we predict properties of compounds by the nature of the oxidation numbers of the compound, the way they are varied, you can predict properties. But that formula, we use it that much. And most importantly for us also, balance redox reactions in which electrons are transferred. So oxidation of fire, guys, whenever there's oxidation, there's also reduction. So whenever an atom loses electrons, then there will be another atom that has gained. It's as good as when someone gives, someone receives. Are you getting? So chimona ngwachipadi nani ifumo. Ifumo ngadi aise ifumo ni chipadi upelele. Iwanga na upula, then padi no upelele. For oxidation, like whenever. So when you write an equation, we don't find the equations where there are electrons. They are there, yes, but those ones are called half reactions. Why? Because the full reaction does not show the electrons. Because one, when electrons are lost by one, the same electrons will be gained by another. So the one that loses electrons becomes oxidized. The one that gains becomes reduced. So those are the things. So we use this one. Why? Because balancing is key, but you will find that these redox reactions are complicated to balance by inspection. You can't easily balance a complex redox by inspection. You need to follow a set of rules for you to balance. You will see them very soon, friends. So now the rules are here. Epa kuikala nomba pa epa kukodile nsakwe. Pama rules. These are the rules, all 7 of them. Ngawaya konka fe buno ma rules. Tiwa na mkuno wa mensha po kutila na fish ba fionsafe. Why? Because the rules are straightforward. So the first one is that element in its free state. My internet is almost tripping. Let me wait a bit. I hope you are getting me now. bazamte otabanchitire bwino lero yo. So all elements in their free state. An element when it's free, in its free state, the oxidation number is 0, regardless of whether it's monatomic, diatomic, or polyatomic. Meaning if you have sodium, oxidation number is 0. So oxidation number is like love. Love. I'm sure you know about love, guys. For you to say you love someone, there should be someone else to love. Not that love or kwatafe yourself. Even Jesus, I can, because the commandment is love your neighbor as yourself. There should be a neighbor. A neighbor may be someone you live with, someone in society, or your close friends. And Jesus happened upon love your enemy. So your neighbor can even be your enemy. You should love them. So now these are the things you can't love yourself. For you to understand. So oxidation number, if oxidation number be love, then it's 0 if it's only for self. So as long as even H2, O2, all these have oxidation number of 0. Even O3, oxidation number of 0 is big because this thing is combined to itself. Even S8, there's sulfur 8. This S8, sulfur is molecular, complicated. So this thing you discover, this sulfur, whatever it is, guys, as long as it's bonded to itself, then the oxidation number is 0. Then hydrogen has a positive +1 oxidation number. Don't confuse when people are about positive, pama metals. Even non-metals can have positive oxidation numbers. So hydrogen has positive oxidation number, which is +1, except in metal hydrides where it is -1. So only in the exception where the hydrogen is bonded to a metal, e.g. sodium hydride and calcium hydride. Calcium hydride is very useful. Mokpanga acetylene, which is one of the organic compounds, the thiene with a Y. So these ones, hydrogen, everywhere you see hydrogen, you know it's +1, except when you see it in a metal. Oxygen is -2, except in peroxides where it's -1. Peroxide is H2O2, K2O2, those are peroxides. Where you have something with oxidation number 1, you are very certain there are 2, and then the oxygens are also 2, because the oxygen should just be 1 there. So in peroxides, oxygen is -1. And in OF2, OF2 is unique. So this one is the most electronegative element that we mentioned. It's more electronegative than oxygen. So in OF2, oxygen will be +2. K, it's an exception. So it's very important that you know it, because if you forget this small thing, so those are the things. Then metallic elements generally have positive oxidation numbers. All of them have oxidation number. In the ion, the oxidation number is the charge on the ion. We already said that. Then in covalent compounds, the negative oxidation number is assigned to the most electronegative atom. E.g., I was explaining OF2. Fluorine is the most electronegative element on the periodic table. So since fluorine is most electronegative, it's the one which will have a negative oxidation number. Meaning in a compound, there's always one with positive oxidation number, one with negative oxidation number. Then the most important are these two now, because we use them to solve. The algebraic sum, meaning when you add the integer values of oxidation numbers in a compound, is 0. So a compound, the total sum of the oxidation numbers is always 0. Then for a polyatomic ion, those ions where there are more than one, there's more than one element, e.g. the carbonate ion, CO3 2-. There, the oxidation number is the charge of the ion. So when you add the oxidation numbers, you must equate them to that value, which is a charge there. Then many elements have multiple oxidation numbers. Not to solve imo. Now solve tamuli N2O nitrogen is +1. To equipsha padi N2O5. Wasana chana yena. Kai nitrogen. No. An element can have multiple oxidation numbers. Like nitrogen, you've seen 0 there, it's in its free state, +1, +2, +3, +4, +5, and +5 again. So there are so many different oxidation numbers. So the rules that you apply is you write oxidation number below the first rule is you write the one you know, the one that you know. How would you know it? Because that's the question. You know it by looking at the rules. Read the rules. Again, my internet is tripping. So you look on the rules. Oxygen now at it's -2. So you put -2 down there. This is CO2, carbon dioxide. As we said, one should be positive, one should be negative, compound. So we are definite that carbon will be positive. Don't restrict positivity to metals, like someone was asking in the morning. That's why I'm emphasizing that. To say, how come carbon? I'm explaining now. When a compound is formed, and there's oxidation states, one should have a positive and the other one should have what? A negative. So now, a power lab will -2. Then you multiply times -2, you have -4. So now these, when you add carbon, which is the oxidation number you're looking for, because the question here is to determine the oxidation number of carbon and carbon dioxide. So carbon -4 equals 0. Then when the minus crosses the equal sign, it becomes +4. Then you are found. That is the case on the next one as well. You say H2SO4, hydrogen, remember from the rules, is +1. LO is -2, and we're looking for the oxidation number of sulfur. So sulfur is in black. Yeah, my blacks. But what are moneka na mudi nante de moneka?